All right. I oftentimes let my students derail me, so I'm going to not let that happen this time. And I wanted to look at a couple of examples with you. Uh, we're not ready to talk about range quite yet. We don't want to talk about range until um, we're not going to talk about range until we talk about transforming the different functions. But just as a quick reminder, when you're finding the domain of something, there's two things that can go wrong. And those two things are you could have a zero in the denominator, or you could have a negative under an even indexed square root. Okay. So for us, when you look at this situation, we just have a denominator. So all we do is we set 4x minus 1 to be not equal to 0. And then this tells us that 4x is equal to not equal to 1, which tells us that x is not equal to 1/4. And then just as a quick reminder, we like to use interval notation in this class. So we're going to write that from negative infinity to 1/4 union 1/4 to positive infinity. Okay. So is there any questions about that? A lot of you did the homework already, and you guys um, maybe saw something like that already. All right. Um, I think this next example is much more interesting. So I'm going to put a star here because maybe sometimes students have difficulty with this type of thing, but in calculus, we kind of want to get good at doing this type of thing. So what's the deal with this guy? Well, the deal with this guy is the index of this radical is even. It's actually, the index is 2. When they don't put any index there, the index is 2. And so what we really need to do is we really need to set 9 minus x squared to be greater than or equal to 0. And we need to solve this inequality. So this is called the quadratic inequality. So I'm going to solve this quadratic inequality. I can't write inequality. There you go. So I think the first thing that we should do is we should factor it. So I think we talked about this last time. Did we? I get confused because I teach multiple classes. When I see this, I'm automatically thinking something, and I want to know if you guys are thinking the same thing I'm thinking. So what do you think when you see this expression right here? Anyone? Nothing. So you're not thinking a difference of two squares like I am? Oh, no, someone did type in the chat box, difference of two squares. Okay, exactly. So in other words, this is really like 3 squared minus x squared. And anytime you have a difference of two squares, we could really write that as 3 minus x or 3 plus x. We want this to be greater than or equal to 0. Okay. So, so we're still in the process of solving this quadratic inequality. In order to solve this quadratic inequality, we need to know where the zeros are. So I think you guys can see that we have zeros. It equals 0 at 3 and negative 3. So what we're going to do next is we're going to divide our number line up into 3 pieces because we have 2 breakpoints. So we divide number line into 3 pieces. So we're going to look at the part going from negative infinity to -3. Then we're going to look at the part that goes from 3 to positive, I'm sorry, -3 to +3. And then we're going to look at the part where we go from +3 to +infinity. Okay. And what I'm going to do is I'm going to create a little table to track what's going on here. So let me put my table right here. So these sort of represent my 3 pieces. Oops. Okay, so you got something like this. So I chopped my real number line into 3 pieces. I'm going to put those 3 pieces at the top here. So this goes from -infinity to -3. This guy goes from -3 to +3. This guy goes from 3 to +infinity. And then along the vertical side on the left there, I'm going to put the different factors of our inequality or function. So I have a 3 minus x and I have a 3 plus x. Okay. And then all I got to do is figure out where each piece is positive or negative. Okay. So I'm going to ask you guys a question. When you look at this first term right here, this 3 minus x, what type of object is this? If I set this y equal to 3 minus x, what type of object would you say that was?
Linear.
That's a line. Great. And is the line, is the slope positive or negative?
Negative.
Negative
What?
slope. And you see that it's going to cross the axis at 3, right? So it crosses the axis right here at 3. But the line is going down. So you know that it's going to be negative past 3 and positive to the left of 3. Does that make sense? Just imagine a line. You can use test points if you like, but we can think more sophisticatedly. We can think of it as a line. Imagine a line with a negative slope and it crosses at 3. What about this next piece? This next piece is also a line, but this time the slope is positive. I look at the coefficient of the x term, it's 1. So the slope is positive. So this line is going like this, right? And where does it cross? When's it equal to 0? It's equal to 0 at -3. So it's equal to 0 right here. And we know that to the right, it's going to be positive because it's going up. And to the left, it's going to be negative. So then this is going to be positive, positive, and then negative, right? And then what I can do is I can just multiply the signs together to figure out where each piece is positive and negative. So a positive times a negative is a negative. A positive times a positive is a positive. And a negative times a positive is a negative, right? So in this particular case, I want to keep the positive parts and throw away the negative parts. So my domain D is going to be -3 to +3. And then the next question is, do you want to include the endpoints or not? And in this case, if you look, right, we want it to be greater than or equal to, because you can have the square root of 0. The square root of 0 is 0. So we're going to include those 2 endpoints. So this would be a square bracket. That'll be a square bracket. And that'll be our answer. Does that make sense to everybody? Any questions? All right. So this method that I kind of outlined where, I take something, I look at the different factors, I split my domain up into different, or I split the real number line up into different pieces, and I look at and see what happens to each of the factors. This is something we're going to do in the future again. So I wanted to show you this to you now in like a safe environment, and then we're going to do it using calculus techniques later. Any questions about this example? We're good? All right, perfect. So for this last guy over here, oh, what's the name of this function? It's h of x. When you look at this guy, what do you notice? What's the first thing that you notice, if anything? Anyone notice anything of interest?
Radical.
Alice notices there's something even, you're right, the radical is important, but Alice is noticing the index. And I don't know if it's obvious because I had to copy this, but the index is 3. So the index equals to 3, which is odd. So when you have an odd index, is there any restriction for the inside? There's not. So the domain just goes from negative infinity to positive infinity. This odd has, this part means no restriction on domain. Make sense? So this is just sort of reminding us of what had happened last class. Okay. All right. So I've taught this class, many times. I just taught this class last semester. I know that students sometimes have difficulty with this table thing. And the other thing that students sometimes have difficulty with is this graphing this piecewise defined function. So just want to highlight that.
Professor, can you switch captionist, please, to Dana?
Of course.
Thank you so much.
Let's see here. From Kate to Dana.